Opening scene, slow, majestic zoom out from Earth, past the moon, the planets, and out of the Milky Way into the vast, glittering tapestry of intergalactic space. Narrator, VO. For as long as we have looked up, we have looked for answers. We exist on a fragile blue marble, adrift in a cosmic ocean of unimaginable scale. Out here, in the silent dark, are more stars than there are grains of sand on all the beaches of our world. And for every star, a potential story, a potential beginning, or an end. Humankind's greatest intellectual journey has been the quest to understand this cosmic arena, to find the rules, the code. We've discovered elegant laws that govern the dance of planets and the fire within stars. From Einstein's E=mc² to the intricate standard model of particle physics, we have sought a single master equation, a God equation, as physicist Michio Kaku calls it, that could explain everything from the instant of the Big Bang to the slow, eventual death of the universe. And yet, the more we learn, the more the universe conceals. Our grand equations only describe a sliver of reality. About 95% of the cosmos appears to be missing, composed of mysterious dark matter and an even more enigmatic dark energy. We are cartographers mapping a new world, only to discover that the map we're drawing covers only the coastlines, while an entire unseen continent lies just beyond our reach. This is the first great mystery. What is the fundamental nature of reality? What is the master code that governs the cosmos? But as we gaze outward, searching for that final theory, we overlook the most profound enigma of all. It isn't found in the heart of a black hole or at the edge of space-time. It's found behind our own eyes. Scene: transition from the cosmic web to the intricate branching network of neurons inside a human brain, which visually mirrors the galactic filaments. The human brain. 3 pounds of soft tissue, composed of the same star stuff as everything else, the same carbon, oxygen, and hydrogen. Yet, this assembly of atoms does something that, as far as we know, no other object in the universe can. It wakes up. It becomes aware. It can contemplate the very cosmos from which it sprang. It feels joy, mourns loss, creates art, and asks, why? This is the second great mystery, the problem of consciousness. How does non-living matter, following the basic laws of physics, generate the private, subjective inner world of the mind? Where is the ghost in the machine? Are these two riddles separate, or are they intrinsically linked? The universe, a vast physical system governed by a hidden code, and consciousness, the strange loop that allows that system to observe and comprehend itself. In this series, we will journey to the frontiers of human knowledge to confront these two titans of the unknown. We will speak with the physicists decoding the universe's blueprint and the neuroscientists mapping the landscape of the mind. Because in solving these puzzles, we may not only find our place in the cosmos, but finally understand what it truly means to be human. Scene: we transition from the abstract montage of Part 1 to a clean archival shot of Albert Einstein at his blackboard, chalk in hand. The camera slowly pushes in on his famous equation, E=mc². Narrator, VO. The search for the universe's master code began in earnest here, with one man and one revolutionary idea, that the universe is elegant, rational, and knowable. Albert Einstein devoted the last 30 years of his life to a single consuming quest, to find a unified field theory that would bind all of nature's forces into one magnificent equation. He failed. The universe, it turned out, was far stranger than even he had imagined. The story of 20th century physics is the story of a great schism, a tale of two empires that, to this day, refuse to unite. On one side, we have Einstein's masterpiece, general relativity. This is the law of the large, a cosmic ballet of curving space and flowing time that governs planets, stars, and the grand architecture of galaxies. It is a world of smooth, predictable certainty, where cause and effect are linked in a beautiful, unbroken chain. It describes gravity not as a force, but as the very shape of the universe. On the other side is the law of the small, quantum mechanics. This is the realm of the subatomic, a world of dizzying paradox and uncertainty. Here, particles can be in multiple places at once. Reality is a game of probability, and the universe behaves like a cosmic casino where the act of observation itself changes the outcome of the game. It is a theory of staggering predictive power, the foundation of our entire digital world, but it is fundamentally chaotic. For decades, these two theories have coexisted peacefully, each ruling its own domain: relativity for the cosmos, quantum mechanics for the atoms. But there are places in the universe where these two realms are forced to collide. The singularity at the heart of a black hole, the first ferocious moment of the Big Bang. In these extremes, the immense gravity of relativity is crushed into the microscopic space of the quantum world. And when the equations of these two great theories meet, they break. The math screams infinity and collapses into nonsense. Physics, as we know it, comes to a dead end. To solve this, to complete Einstein's dream, we need a new theory, a deeper theory, a theory of everything. The leading and most controversial candidate is a radical idea that reimagines the very fabric of reality. It's called string theory. As physicist Michio Kaku describes it, it suggests the universe is a cosmic symphony, that the fundamental constituents of nature are not point-like particles, but tiny, one-dimensional, vibrating strings of energy. Each unique vibration corresponds to a unique particle. The electron is one note, the quark is another, the photon is a third. Physics becomes the harmony of these vibrating strings. Chemistry is the melody you can play with them. This beautiful musical idea solves many of the mathematical paradoxes that plague physics. But this solution comes at a mind-bending price. For the mathematics to work, the universe cannot have just the 3 dimensions of space we know. String theory demands the existence of at least 10 dimensions. Our universe, the entire cosmic web of galaxies and stars, may be just one membrane, or brain, floating in a much vaster, higher dimensional reality we can never directly see. A hidden hyperspace all around us. Scene: we float in the abstract higher dimensional hyperspace introduced in Part 2. Our universe, our 3D world, is a vast glowing membrane. Other similar membranes drift nearby like ghostly sheets in a cosmic ocean. Narrator, VO. This hidden hyperspace is not just an empty stage. According to string theory, it could be populated by other universes, other brains, existing parallel to our own, separated by a dimensional gap smaller than an atom's width. This gives rise to one of the most staggering ideas in all of science, the multiverse. Our Big Bang may not have been a singular event, but simply the result of 2 of these cosmic membranes colliding, releasing a titanic burst of energy that grew into the cosmos we know. It's a breathtaking vision, a universe of universes, all born from the music of strings. It elegantly resolves the clash between Einstein's relativity and the quantum realm. It seems, at first glance, to be the final theory, the master code we've been searching for. But this grand cosmic symphony has a fatal flaw, a silent note that has led many physicists to call it a crisis point for science itself. The problem? We can't hear the music. The strings are proposed to be a trillion times smaller than a proton. The energy required to probe something so minuscule is astronomical, far beyond anything we could ever build on Earth. The theory is, for now, completely untestable. And so, physics finds itself in a strange new land. For centuries, science has been guided by a simple principle. You make a prediction, and you test it with an experiment. But what happens when your most promising theory makes no testable predictions? Does it remain science, or does it cross the line into philosophy, into a kind of mathematical faith? Has our search for the ultimate truth led us to a place beyond the reach of human inquiry? This impasse has forced some thinkers to re-examine our most basic assumptions. Perhaps the problem isn't with our theories, but with our perspective. We have been trying to create an objective picture of reality, a God's eye view of the universe as it exists independent of us. But quantum mechanics, the most successful theory we have ever created, screams that this is impossible. It tells us the observer is not a passive spectator, but a fundamental participant. This is most famously demonstrated in the double-slit experiment. When you're not looking, a particle like an electron behaves like a wave, passing through two slits at once. But the moment you try to observe which path it takes, it chooses a single path, behaving like a simple particle. The act of measurement fundamentally changes the outcome. Reality at its most fundamental level seems to depend on whether or not we are watching. This forces us to confront an unnerving question that physicists have dodged for a century. What constitutes an observer? Is it a Geiger counter, a camera, or does it require something more? Does it require a mind? Has the ghost in the machine been hiding in our equations all along? We hit a wall trying to understand the universe. Now we must turn our gaze inward to the very thing that is doing the looking.
The fabric of reality hinges on the act of observation. Then the greatest mystery in the cosmos may not be in the stars, but in the stargazer. For centuries, we treated the mind as the domain of philosophers and poets. But in the 21st century, we have finally begun to map this inner world with the rigorous tools of science. We have laid the brain bare. We now see it for what it is, the most complex object in the known universe. 86 billion neurons, each a sophisticated biological processor, woven together by nearly 100 trillion synaptic connections. There are more connections in a single cubic centimeter of brain tissue than there are stars in the Milky Way galaxy. This is the hardware, an electrochemical machine of unimaginable intricacy. From this biological computer, everything we are emerges. Every memory, every fear, every flash of insight is a storm of electrical signals firing across these neural pathways. Neuroscientists call these the easy problems. In principle, we can trace them. We can watch the brain as it recognizes a face, processes a sound, or learns a new skill. We can pinpoint the correlates of consciousness, but we can't find consciousness itself. This leads us to what philosopher David Chalmers famously termed the hard problem. It is the chasm between the objective mechanics and the subjective experience. We can describe precisely how your eye receives photons of a 650 nanometer wavelength. We can follow the electrical impulses as they cascade through your brain. We can identify every neuron that fires in response. But nowhere in that chain can we find the experience of the color red. Why is all that information processing accompanied by a private inner feeling? Why does it feel like something to be you? This is the mystery of qualia, the raw subjective qualities of experience, the bitterness of coffee, the warmth of the sun, the melody of a song. They seem to be the most real things in our lives, yet they are nowhere to be found in our scientific description of the world. To illustrate this gap, consider a famous thought experiment. Imagine Mary, a neuroscientist who has spent her entire life in a black and white room. She has learned everything there is to know about the science of color vision. She knows every detail about the physics of light, the anatomy of the eye, and the neural processes that occur when someone sees a red rose. She knows more about the color red than anyone in history. The question is, if we suddenly release Mary into the colorful world and she sees a red rose for the very first time, does she learn something new? Intuitively, we all know the answer is yes. She learns what it is like to see red. This new piece of knowledge, this raw feeling, was absent from her complete physical understanding of the world. This simple story exposes the profound limits of a purely physical description of reality. It suggests that our consciousness, our inner world of experience, is not just another data point. It is an entirely different category of existence. Our science has given us an exquisite map of the machine, but it has yet to find the ghost that lives within it. Is consciousness merely a clever illusion produced by a complex computer? Or is it a clue that our understanding of reality is missing a fundamental ingredient, one that links the mind that asks the questions to the very cosmos it is questioning? This is the ultimate mystery, the ghost in the machine. Now, let's dive deeper to how it all began. Faced with the profound gap between the brain and the mind, science stands at a crossroads. Two paths diverge, each leading to a radically different vision of reality. The first path is the safe one, the one favored by mainstream neuroscience. It claims that consciousness is nothing more than a magnificent illusion. This idea, known as emergentism, suggests that our sense of self is a byproduct of immense complexity. It's a trick the brain plays on itself. Consider an ant colony. No single ant possesses the blueprint for the nest. Yet together they build elaborate structures and solve complex logistical problems. The intelligence of the colony emerges from the simple interactions of its millions of individual parts. In this view, consciousness is the same. No single neuron is aware, but from the coordinated firing of 86 billion of them, the grand illusion of a unified I emerges. It's an elegant, economical solution. The ghost is not a separate entity, but simply the word we use to describe what the machine does. But this explanation, for all its tidiness, still fails to explain why it feels like anything at all. Why isn't it all happening in the dark, without any inner experience? This lingering question has pushed some thinkers down the second, more radical path. This path suggests we have the entire problem backward. What if consciousness is not a late-breaking emergent property of complex matter? What if it's a fundamental intrinsic property of the universe itself? This is the central idea behind theories like panpsychism and integrated information theory. They propose that experience is woven into the fabric of reality at a foundational level. An electron doesn't think, but it may possess a flicker of raw proto-consciousness. As matter organizes into more complex systems, like a brain, this fundamental property integrates and amplifies, blossoming into the rich inner world we know. Consciousness doesn't emerge from matter, it's what matter is from the inside. This startling idea forges a potential bridge back to the other great mystery, the strangeness of the quantum world. For a century, physics has been haunted by the observer effect, the fact that reality seems to change when we look at it. The controversial Orc-Or theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, takes this link literally. It suggests that consciousness doesn't arise from the classical firing between neurons, but from quantum computations occurring inside tiny protein structures within them called microtubules. Each time these quantum processes collapse from a state of possibility into a single reality, a moment of conscious experience occurs. If this is true, then consciousness is not something the brain produces. It is something the brain harnesses. A quantum phenomenon that connects our inner world directly to the fundamental workings of the universe. The ghost in the machine is not a ghost at all. It's a quantum resonance with reality itself. Our science of the external world, physics, and our science of the internal world, neuroscience, might just be two different languages describing the same unified whole. We are left with a staggering possibility. The two greatest mysteries, the nature of the universe and the nature of the mind, may not be two mysteries at all, but two sides of the same cosmic coin. The nebula is a vast neural network, the melody a symphony of consciousness. We are faced with an altered paradigm. The cosmos itself may be harboring a precedent misunderstanding. Nature is qualia, the warmth of the sun. The universe is a brain. The mind is a nebula. Faced with the profound gap between the brain and the mind, science stands at a crossroads. Two paths diverge, each leading to a radically different vision of reality. The first path is the safe one, the one favored by mainstream neuroscience. It claims that consciousness is nothing more than a magnificent illusion. This idea, known as emergentism, suggests that our sense of self is a byproduct of immense complexity. It's a trick the brain plays on itself. Consider an ant colony. No single ant possesses the blueprint for the nest. Yet together they build elaborate structures and solve complex logistical problems. The intelligence of the colony emerges from the simple interactions of its millions of individual parts. In this view, consciousness is the same. No single neuron is aware, but from the coordinated firing of 86 billion of them, the grand illusion of a unified I emerges. It's an elegant, economical solution. The ghost is not a separate entity, but simply the word we use to describe what the machine does. But this explanation, for all its tidiness, still fails to explain why it feels like anything at all. Why isn't it all happening in the dark, without any inner experience? This lingering question has pushed some thinkers down the second, more radical path. This path suggests we have the entire problem backward. What if consciousness is not a late-breaking, emergent property of complex matter? What if it's a fundamental, intrinsic property of the universe itself? This is the central idea behind theories like panpsychism and integrated information theory. They propose that experience is woven into the fabric of reality at a foundational level. An electron doesn't think, but it may possess a flicker of raw proto-consciousness. As matter organizes into more complex systems, like a brain, this fundamental property integrates and amplifies. Consciousness doesn't emerge from matter, it's what matter is from the inside. This startling idea forges a potential bridge back to the other great mystery, the strangeness of the quantum world. For a century, physics has been haunted by the observer effect, the fact that reality seems to change when we look at it. The controversial ORC-OR theory, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff, takes this link literally. It suggests that consciousness doesn't arise from the classical firing between neurons, but from quantum computations occurring inside tiny protein structures within them called microtubules. Each time these quantum processes collapse,
the world is full of fascinating paradoxes, isn't it? We hope today's facts truly bent your mind. If you're ready for more daily revelations that challenge the norm, subscribe to Mindbenders. Don't forget to ring the bell so you never miss a new video. Until next time.